Hi everyone, I'm Prabha, Assistant Professor of Chemistry, A.D.M. College for Women, Autonomous, Nagapattinam. Today's class we will discuss about free radicals, their synthesis, the reactions, as well as reduction of free radicals. So as we understand free radicals, those are the species that contain odd electrons and they are formed by the homolytic fission of covalent bonds. So when covalent bonds undergo fission, particularly homolytic fission of covalent bonds that yields free radicals, and those species that contain free electrons, it may be as one or more odd electrons. We understand how they are produced. Mostly they are produced by the reactions when they are carried out at high temperatures or in the presence of other free radical generating substances like peroxide. Some examples for free radicals include methyl free radicals, triphenyl methyl free radical, nitrogen oxide molecule. All these species can be classified as also sometimes nitrogen dioxide will have a tendency to have a transient behavior as free radicals. So all these can be classified as some examples for free radicals. As we understand, based on their stability, their classification is as stable free radicals as well as transient free radicals. Stable free radicals also referred as free radicals of long life, and those which are classified as transient free radicals include that which these free radicals are of short life. So as we understand the synthesis of free radicals, in 19,100, Gomberg, the scientist, was the first to synthesize free radicals, and he succeeded in 1897. The first free radical generated as tetramethyl ethane as a molecular compound. After that, the free radical properties were examined, and similarly, hexaphenyl ethane were synthesized following that. So, as we understand, the reaction is between corresponding chloride and the presence of silver and benzene, thereby yielding free radical molecules. As we understand the characteristics of free radicals, or how Gomberg classified these under the head as free radicals rather than as neutral molecules, is based on this factor that those substrates produced yellow compounds when they were subjected to heating, and they mostly showed high reactivity, thereby undergoing addition reactions with halogen, oxygen, hydrogen, and metallic sodium, magnesium, also with other unsaturated olefins, thereby showing their high reactivity. Also, the presence of free electron pairs confirmed their paramagnetic behavior, and the molecular weight ranges from 416 to 486, depending upon the number of aryl groups that are attached to the carbon group. Hence, Gomberg classified these under free radicals, as we understand that this special class of compounds that contain odd electrons, one or more odd electrons. So as we understand synthesis of free radicals, the first synthesis being referred as Gomberg synthesis, where triaryl methyl free radical is being produced from corresponding chloride by the reaction with silver in the presence of benzene solvent. So the reaction being represented here, where the corresponding fluoroderivative of the corresponding free radical reacts with silver in the presence of benzene to form a radical, and the required triaryl methyl chloride has been formed from triaryl carbinol on treatment with acetyl chloride, correspondingly produces this triaryl methyl free radical. The triaryl methyl free radical, as we understand, has been produced so, and the required triaryl carbinol involved in the synthesis is produced from corresponding ketone when it is treated with organometallic derivative. So correspondingly it forms the required carbinol, and this carbinol being treated with acetyl chloride such that it forms triaryl methyl chloride. So the next reaction being by reduction of triaryl cation. So first triaryl cation is formed and it is reduced. Correspondingly, we understand as the previous equation there, from carbinol, triaryl carbinol, when it is treated with mineral acid, it forms the corresponding triaryl cation, And the triaryl cation is reduced using stannous chloride or vanadis chloride or titanous chloride. Thereby, vanadium here as represented in this equation is oxidized to its higher valency state, and the required triaryl methyl free radical is being formed in this reaction. The third one is abstraction of metallic potassium from organometallic derivative. So first we prepare the organometallic derivative, and from that abstraction of the metal is being followed. So the first reaction involves corresponding methyl ether of triaryl carbinol is taken, and it is treated with metallic potassium such that it forms the corresponding organopotassium derivative, and the organopotassium derivative is treated with tetramethyl ethylene dibromide such that it forms the corresponding triaryl methyl free radical. So reactions of free radicals, first one undergoes readily with addition reactions. So first one being reaction with metals with metallic sodium, the corresponding metallic derivative being formed, and with magnesium it acts as MgBr, thereby forming the corresponding organometallic derivative, and with halogens it forms a corresponding halogen derivative, and with oxygen it forms triphenyl methyl free radical, forms corresponding peroxides. Peroxides are also formed as byproducts when they are reacting with sodium peroxide. Similar product is being formed in this reaction. The other reaction being with hydrogen, the reduced product is being formed by triphenyl methyl free radical. So triphenyl methyl free radical will undergo reduction in the presence of hydrogen and platinum, or otherwise in the presence of zinc and acetic acid, to form the corresponding reduced product. It is represented as PH3CH, where PH represents phenyl groups. So triphenyl methyl free radical undergoing reduction in the presence of zinc and acetic acid, or in the presence of zinc and hydrogen and platinum. Similar reduced product is also being formed when the reaction is taking place between triphenyl methyl free radical and hydrazine, or otherwise with phenyl hydrazine, or with phenols. Correspondingly, in phenol, the specificity of orientation as the para positions being OH groups present in the product is being obtained. The next one being reaction with nitrogen oxide. Reaction with nitric oxide, and if it is so, the corresponding nitro derivative, and with nitrogen dioxide it forms corresponding nitro and nitrite compounds being formed in the reactions. Next, when the addition reaction takes place with parabenzoquinone, corresponding ether derivative of triphenyl methyl free radical is obtained undergoing addition reactions. And the next are the reaction with unsaturation, where the volcanic system, the free radical acts across the double bonds, thereby the resulting product here succinic derivative of this, correspondingly with triphenyl substituted products are being obtained. The other reaction is with other radicals, which is triphenyl methyl radical can add upon with other free radicals, resulting in new formed products or newly formed derivatives. So as we see to the reactions of triphenyl methyl free radicals, the first being addition reactions, and now reduction reactions being taking place here. The reduction as being when it is taking, the reaction takes place between ferrichloride and silver chloride, where ferrichloride is reduced to ferrous chloride, and silver chloride being reduced to metallic silver, corresponding halogen derivative of triphenyl methyl free radical being formed in these reactions. Next the reaction is similar to metal displacement reactions. There is also displacement reactions being taking place, and triphenyl methyl free radical reacts upon the halo derivatives of these compounds. Correspondingly, new generated free radical being formed in the displacement reactions. Other reaction being disproportionation reaction, where one molecule of three molecules react in the presence of sunlight, the reaction is more favored, and in the presence of sunlight, the triphenyl methyl free radical, where one of the molecule getting reduced and the other molecules are oxidized to the corresponding product. Other reaction being irreversible dimerization. Irreversible dimerization is more favored in the presence of mineral acids or otherwise in the presence of highly active halogen containing acids like hydrochloric acid, and reduced to the product being formed as the corresponding substitute, that is the ring being introduced into the system. So as we understand the rearrangement reactions of triphenyl methyl free radicals, they undergo rearrangement in the presence of peroxide, particularly when they react with unsaturated ketone, thereby resulting in the formation of the rearranged product, and that is the point of radical formation shift being there and along the carbon atom, and next undergoes rearrangement, thereby forming the corresponding products here. The second reaction with an unsaturated olefinic system, where in the presence of ketone, triphenyl methyl free radical forms the corresponding newly formed position of the free radical and the shift of phenyl group, because to release the steric hindrance or the steric parameters based on the comparatively to the methyl group and the phenyl group. Phenyl groups make the shift over there to the corresponding carbon atom, and thereby resulting in the formation of the regenerated product that is being used for this process and the rearranged molecule obtained as a product. So the next reaction with sulfur dioxide, triphenyl methyl free radical, when it reacts with sulfur dioxide or in presence of sulfur dioxide, shows its paramagnetic behavior, thereby converting itself to triphenyl methyl cation, releasing one electron, thereby confirms the presence of odd electron in the corresponding species. Reduction of free radicals. As we understand, free radicals are those substances or those species that contain odd electrons, thereby they can be also detected by their paramagnetic behavior, or based on the presence of the magnetic behavior of free radicals, reduction of free radicals is being facilitated. In that cases, every electron has its spin orientation, and because of the spin orientation there arises magnetic field. Because of the arising magnetic field there lies net magnetic moment. So if we consider neutral molecules, then the field associated with that, or one electron will show a spin up and another one will show a magnetic field as spin down, thereby nullifying each other's magnetic field. But in case of free radicals, there will be net magnetic field possessed by the free radicals, and correspondingly magnetic moments will be there for free radicals, and hence it is possible to detect those based on the magnetic behavior. But if this is being carried out, that is being a less sensitive process when it is subjected to any magnetic transformations. So the other one which we utilize it up is electron spin resonance or electron paramagnetic resonance, where we understand that if we subject any solution containing free radicals or other gaseous free radicals are subjected to an external magnetic field, in that case the electrons will orient itself, or the magnetic field will be oriented in such a way that there will be two possible positions. One is the stable orientation, and when they are subjected to absorption of energy, they will transform itself into unstable orientation. So the changes in the orientation then becomes measurable. Thereby this process can be considered, that is electron spin magnetic resonance or electron paramagnetic resonance or electron spin resonance can be considered as a best technique for reduction of free radicals, and this is applicable for solutions even at lower concentration, and this ranges even for a lower concentration of the free radicals if they are present in solutions up to 10 power minus 7 molar values. And also this particular deduction using electron paramagnetic resonance or electron spin resonance, the deduction of these free radicals are most liable even when that is applicable for free radicals which are less stable. So this can be extended to free radical deductions of metal free radicals. So based on these magnetic behavior and changes in the orientation of magnetic properties, free radicals can be very well identified and detected. Thank you all.